Super Condorcet Winners and Limit Coalitional Manipulability of IRV by Élie de Panafieu, François Durand, and Guillem Perarnau. Let's start with plurality with runoff, where the two candidates with the most top votes advance to a final runoff. Consider this preference profile. Here we have 36 voters who rank candidate C1 first, then C3, C2, and C4. Similarly, other groups have different preferences. In the first round, each ballot counts as a vote for its top-ranked candidate. The plot on the right shows the candidates' scores. Candidates C3 and C4 are eliminated. Their supporters transfer their votes to C2, making C2 the winner. But let us go back to the original situation. If voters from the first and fourth group strategically vote for C3, then C3 wins, and it is in their interest to do so because they prefer C3 over the original winner C2. This is called a coalitional manipulation. Now consider instant runoff voting, where the candidate with the fewest top votes is eliminated in each round. We take the same preference profile as before. First, candidate C4 is eliminated and its votes transfer to C3. Then C2 is eliminated, making C3 the winner. And here, unlike with plurality with runoff, it can be shown that no coalition can manipulate the outcome. To compare voting rules, we use their limit CM rate under impartial culture, which is the limiting probability, when the number of voters tends to infinity, that a profile drawn uniformly at random is coalitionally manipulable. Kim and Rausch showed that this limit equals 1 for several major rules, almost all positional scoring rules such as plurality and Borda, but also Maximin and Coombs's rule with 3 candidates. They found 2 exceptions, veto and the rule that now bears their name. Lapelli and Vallones later identified another exception with a lower limit CM rate than veto or Kim-Rausch, plurality with runoff with 3 candidates, which coincides with IRV. Unfortunately, we show in this paper that this positive result does not extend to 4 or more candidates for plurality with runoff, which then also has a limit CM rate equal to 1. What about IRV for 4 or more candidates? To investigate this, we rely on the recent notion of super Condorcet winner. Let's illustrate this with candidate C3 from our initial example. In the full profile, C3 has more than a quarter of the votes. In each 3-candidate sub-election, without C1, without C2, or without C4, C3 still has more than a third of the votes. And in each 2-candidate sub-election, that is in every pairwise comparison, C3 holds more than half of the votes, thus satisfying the classical definition of a Condorcet winner. Together, these conditions define a super Condorcet winner. When there is a super Condorcet winner, IRV is not coalitionally manipulable. It is not a necessary condition, but in empirical datasets, more than 99% of profiles where IRV is not coalitionally manipulable do admit a super Condorcet winner. Here are our theoretical results. We first show that with high probability, the existence of a super Condorcet winner is equivalent to IRV not being coalitionally manipulable. As a consequence, to compute the limit CM rate of IRV, it suffices to compute the limit probability that a super Condorcet winner exists. We then prove that for every number of candidates, this limit probability is positive, and we derive a closed-form expression for it as a Gaussian integral. Taken together, these results prove that the limit CM rate of IRV is strictly below 1 and give an explicit expression for it. Finally, we sanity check our theoretical results against Monte Carlo simulations. On the x-axis, the number of voters in log scale. On the y-axis, the probability that IRV is coalitionally manipulable. Each solid curve shows, for a given number of candidates M, the probability that IRV is coalitionally manipulable, estimated by Monte Carlo simulation. The dashed lines show our theoretical limits as the number of voters tends to infinity. The simulated curves match the predicted limits closely, confirming our results. Let us conclude with a few directions for future research. For Condorcet consistent variants of IRV, current manipulation algorithms are not efficient enough to assess empirically whether these rules are more robust than IRV itself, so it would be interesting to have theoretical results on their manipulability. More generally, we would like to have a complete picture of the limit CM rates of all standard voting rules. Ultimately, our goal is to determine the optimal limit CM rate in impartial culture among a broad class of reasonable voting rules. This would either confirm the superiority of IRV or identify new voting rules worthy of further empirical study.